In this video, we're going to learn about the equality of complex numbers, which sounds fancy, but it's actually a very simple idea, which I'm going to go ahead and prove, which is going to make it look a little scarier. Please don't worry about that. You are not required to prove it. I'll go ahead and show you why, just so you know it has a reason. But once I have this idea, this equality, I can go ahead and solve these two questions here, which look quite difficult because there's two unknowns, x and y. A and B, and there's only one equation. These are two different questions. Usually we wouldn't be able to do that. So the idea of equality of complex numbers is simply all the real numbers on the left equal all the real numbers on the right. All the imaginary numbers on the left equal all the imaginary numbers on the right. Just a quick example, 2 minus 3i is equal a plus bi. That'd be the simplest form. That just means a is equal 2 and b is equal minus 3. All the real numbers, 2 equals all the real numbers a. All the imaginary numbers, minus 3i equals bi. Well, the two i's cancel, and we're just left with b is equal to minus 3. I'll go ahead and prove it with more letters, if you don't mind, because what it really means is a plus bi is equal to c plus di. Sorry, when a plus bi is equal to c plus di, that must mean A is equal to C and B is equal to D. So I'd like to go ahead and prove that. Now, like I said, don't worry, you should be able to follow along. It's not very difficult, but you aren't expected to do it each time. So I will just play around with this, mainly because I know how to do it. I'm not smart enough to have taught this up on my own, unfortunately. So it's A minus C, I'm just taking C from both sides, is equal di minus bi, took bi from both sides. A minus c is equal to d minus bi. I just equated out factorized out the I. And I'll go ahead and square both sides. Now the idea of squaring both sides, it'll be obvious later, it's to find out that something's bigger than 0. In this part at least. And that's going to be really useful to us. Sorry, my voice is going a little there. So a minus c squared is equal to d minus b times I squared, all of that squared. And now remember, when two numbers are squared, it is just d minus b, that part squared, and this part squared. So what's I squared? I squared is minus 1. So a minus c squared is equal to minus 1. Well, let me just write minus d minus b squared, minus 1 multiplied by d minus b. Now let's add this to both sides and we'll get a minus c squared plus d minus b squared is equal, what's left on the right is 0. Now this is actually enough. This has proven it for me. You might not see why, but I'd love you to pause the video and check why am I saying that a now equals c? A must equal C. B must equal D. What about this line is telling you that? I'll tell you in a moment, but please pause it and think about it first. So the reason here is this is a number squared. That means this must be bigger than 0. This is a number squared. That means this must be bigger than 0. So what two numbers can you think of that are both bigger than 0, bigger than or equal to 0, that add together to get 0? Nothing exists except for 0 plus 0 equals 0. That's the only thing that could work here. Which means, therefore, a minus c must equal 0 and d minus b must equal 0. So a equals c and d equals b. We've proven it. That's that we've proven the equality of complex numbers, which is going to be really useful because it allows us to solve lots of questions that exams like to ask. For example, these two here. I'm going to go ahead and rub these out and we will start part 1. So here's part 1. First thing I'll do is multiply it out a bit, expand this bracket out. Basically I just want to get all the real numbers, all the imaginary numbers. Like at the moment, is 2 a real number? Or is it going to multiply by imaginary? Is x, well it's not going to, but is x is a real number, but it's going to multiply by an imaginary number. making it an imaginary number itself. So let's multiply this out. We'll get 2x plus 3xi plus y is equal to 7 plus 6i. So now we can get all the real numbers. All the real numbers on the left are 2x plus y. And they are equal to all the real numbers on the right. 7. That actually doesn't help us. We still have two unknowns and we can't solve that question. But what about the imaginary numbers? We have 3xi is equal to 6i. Divide both sides by I though, and we're just left with 3x equals 6. That one is really easy to solve. We just get x is equal to 2. And we can go ahead and solve y by writing 2 times 2, put x in for 2, plus y is equal to 7. Y is equal to 7 minus 4, y is equal to 3. That's our two answers. That's our answer to part 1. X is 2 and y is 3. Now I'm going to need to rub this out to do part 2 because it's actually a lot longer. It would be more appropriate for higher level Leaving Cert students or more advanced students, wherever you are in the world, whatever type of secondary level education you're doing. More advanced students would be more expected to do this question. It's not especially difficult, it's just long and awkward. So sometimes people like to give those type of questions. I won't bother writing this out again. So just like part 1, I'm going to have to expand this out to have all the real numbers on the left, all the real numbers together, and all the real numbers together on the right. All the imaginary numbers together, all the imaginary numbers on the right. Now that doesn't mean I can't play around with it first. Just like here, I can multiply it out first. One thing I'd like to do is get rid of this bottom row. Bottom row, I cannot work with it. Because I don't know, is this 7 a real number? Well no, it's divided by an imaginary, making it itself an imaginary number. But I know it has real numbers in it. When I divide a real number by an imaginary number, I'll get a combination of the two. So this is really horrible for me. But don't worry, there's a simple solution. 7 plus 4i equals 2 plus bi. Multiply both sides by this. A minus I. Multiply both sides by a minus I, and we'll get rid of the denominator. So now we're just left with left side all nice for us, and let me write it out again. 7 plus 4i is equal to 2a minus 2i plus abi minus bi squared. Let's clean this up. 7 plus 4i is equal to 2a, all the real numbers, 2a. I squared is a real number, it's minus 1. Minus 1 times b is plus b. Minus 2i plus abi. Okay, so if we equate these out, we get the real numbers. Is 7 is equal to 2a plus b. And the imaginary numbers are 4i is equal to 2 minus 2i plus ab. Okay, so what we found here is actually a simultaneous equation. A difficult one, well not very difficult one, but not a standard a plus b one. So how do we do this? We go ahead and rearrange the bottom row so it's a equals or b equals. We use the substitution method. So first I can just get 6 is equal AB, which that means A is equal, well sorry, let me write AB is equal 6 just to help some people out. A is equal 6 divided by B. So with this bit of information, I'm going to go ahead and rewrite this first one. I told you this was a bit longer and messier. I'm going to go ahead and write this line. 7 is equal to 2 times 6 over B plus b, and then let me multiply everything by b. I get 7b plus 12, equals 2 times 6 is 12 plus b squared. We have a quadratic. Let's go ahead and rearrange it. B squared minus 7b, take that over this side, plus 12 is equal, well it should be equal 0 here, but it's the same thing. And then, is this a simple one? 3 times 4 it looks like. Let's hope so. equals 0, 3 and a 4. Let's see, we need them both to be minus. So that is b is equal to 4, b is equal to 3. Not quite finished yet, we still need a, but it's nice and easy, a. A is equal to 6, 6 over 4, or a is equal to 3 over 2. There's one of our answers. Or the other answer is a is equal 6 over 3, a is equal to 2. Here's our other batch of answers. Let me put them together. So when a is 2, b is 3. When a is 3 over 2, b is 4. That's the answer to that question. These are loved by examiners. This would be a nice simple one. This would be a little more complex. But like this one asks lots of things. It asks you how to rearrange a equation. It asks you how to do a quadratic equation. It asks you to equate both sides. The examiners love this. Make sure you're able to do them, or you'll probably miss out on at least one question in an exam. Thanks for watching and have a good day.